lots of hidden talent among us. So in the next few months, you'll be seeing presentations on all sorts of wonderful and interesting topics that were requested by our members, presented to us by our members for the coming year. So if you have any ideas for what you'd like to see or something you'd like to present, see me. And now, once again, the Prince of Food.
Well, my name is Bill Townshend. I'm the project manager for the Miami-Dade Soil and Water Conservation District, which is a subdivision of the State Department of Agriculture. We're allowed to exist here in the county basically by the grace of the Department of Agriculture. We don't get any funding from the state, so whatever we do, we try to have programs that fund our work that we do. In the early 1980s, Dade County came to our agency because we were part of the Department of Agriculture, and they said, "Have you ever heard of a product called mill organite?" I said, "Yeah, we have." And we talked about it some. I went home and talked to my dad, and he was a golfer. And he said, "My goodness, they use mill organite on all the golf courses. And it's made from sludge from Milwaukee." And Dade County came to us and said, "We have mountains of this material, and we'd like to see if we can recycle it into agriculture safely." One of the things we really had going for us is Miami is a tourist town, so heavy metal concerns in Milwaukee material is not the same as ours. We don't have industry dumping heavily into our waste stream, so metals is not a concern. So the next thing was that how safe the material should be. So we started working on distributing the material, and in the very beginning, just the material that was dried and treated from the sewage treatment plant was fine to land applied in agriculture, especially the citrus industry. So we started applying this material to the citrus industry, and there was still a lot of people that were uncomfortable with the pasteurization that the sewage treatment plant did. And there's another process that further pasteurizes this material. While we were working with the material, when we got it to about 70% or 60% solid or 30% water, and put it in big piles, when I go into it with a front end loader, the heat hit me in the face. And I said, "Oh my goodness, this stuff heats up all by itself." So next thing I thought, I wonder if it will pass air or breathe. So we took some material, and I took an old irrigation pipe, and I drilled to the end of it, and I wrapped some string around it, and I piled 40 tons of the sludge on top of the pipe, and I put an air blower and a little Briggs and Stratton motor, and I blew air into it, and took a mosquito fogger, and fogged it up a little bit, and sucked the fog in, and out came the material, the fog real evenly. I said, "Wow, this stuff will breathe." So we started on a saga with the engineers at Dade County to perfect the composting of this sludge material. And what we came up with now is at Black Point we have pipes buried under the ground, and then there's a membrane over that and some crushed rock, and then a grading. And we put 400 tons of this material in a pile over these pipes. And then when you get it at about 70% solids and 30% water, it'll start heating all by itself. But with the air, we can add oxygen to this material, which feeds the bacteria, and it even gets hotter and hotter. Well, we were able to attain temperatures of 190 degrees. Well, pasteurization in the state law says that they want 131 degrees for 3 days to make it what they call AA material, which is unrestricted. You can sell it in Kmart, you can use it, it's deemed very safe. Well, we found that, we could get 190 degrees. So, as we speak, out at Black Point, we make about 10,000 tons a year of this sludge product that reaches 190 degrees for 21 days. Then we test it for what they call fecal indicators. We look for fecal coliform and fecal streptococcus, which are the two hardest to kill. We found that at 131, you weren't killing all the fecal strep. And so 160 does a good job. 190 really does a better job. So after it's composted for 21 days, then we test it for the fecal indicators to make sure there's none there. When we know if there's no fecal strep or fecal coliform, there's no hepatitis or any of the human diseases because the heat's taking care of all that. The other thing that it does is if there's any weed seeds in this material, it'll kill the weed seeds. What we did find out before we composted this material is there was 2 seeds that went through the sewage treatment process that didn't kill the seeds. One was we would have all kinds of volunteer tomato plants. Tomatoes won't go through the digestion. The other thing was they had lots of pot plants that were.
We need some of that shit.
Yeah, and then the employees caught them, and they had a little pot patch, out behind where they were doing the sludge, and of course they got busted. It was a big scandal and everything, but so they'll just volunteer right out of the material. Of course, after we heat treat it, that gets rid the digesters at the sewage plant. So this is a very slow release material. The other good thing about it is, especially in the citrus industry, I went up to A. Duda and Sons, Bell. They have 25,000 acres of citrus and on ball bearing sand. And the first thing I noticed when I got there is all the irrigation ditches were full of pea green soup looking water, because all their nutrients and chemical fertilizers were in the ditches instead of on the land. So we put 3 tons of the acre, which isn't very much of this, a year for 3 years, and their canals are clear because it was holding the nutrients up onto the land. Cation exchange rate, I don't know if you understand what that is, but it's 39 to 1. So this will hold 39 molecules of water, or 39 molecules of water with fertilizer mixed with it for every molecule of the sludge. So it looks like a big magnet or like a sponge. And so what the farmers have done is they put this out first, and then they put their granular fertilizer on top of this. And then when they have a rain or they irrigate, normally with most water-soluble nitrogen products, what the roots don't take up ends up in the groundwater. It goes right on past the plant. By using this, they were getting 3 and 4 irrigations out of an application of commercial fertilizer. So not only did this have a good nutrient value, but it did a lot of other things, for the soil. The other big thing about any kind of organic additions, especially in the sandy and rocky soil we have in Dade County, is that we need bacteria in the soil for the roots to take up any kind of nutrients. It's called the mycorrhizal bacteria. And if you add the right kind of bacteria to your soil, then all of a sudden your fertilizers become more effective and the plants are healthier. And then you don't need to spray them because healthy plants resist adverse conditions, they resist disease. Healthier plants do a better job. So we've learned a lot with this. I've done many papers at the University of Florida. We have a lot of research that was done with this material. We did a study with the U.S. Geological Survey people because our drinking water is so close to the surface of our land. We did different application rates of this material and tested the groundwater. It came out that this made the groundwater cleaner because, again, the chemicals didn't go through the rock. It stayed up in the top fraction of the soil. Not only did you keep your nutrients up there, but all your insecticides and pesticides are designed to be degraded by the sun. And so if you get it in the top fraction of the soil and keep it there, then it degrades with the sun and it's much safer with the groundwater. So Durham wouldn't even let us talk about this until we did that study. And we really, Durham first was in power. Tony Clemente was the first guy. He put his finger in my chest and said, "You'll never use an ounce of this stuff in Dade County." Well, 20 years we've been using it safely, never had a problem. And some people were squeamish. Yeah, and he didn't know the science about it and understand what was going on. I love agriculture. I would never do anything to poison the land or anything else. So I ever thought that something like this was wrong, I wouldn't do it. I can do something else for it. But I really believe in this. We were talking about an old product from the 60s. I'm an old hippie from the 60s, and I hope to think that I'm making a difference. Saving the planet starts with every one of us. And chemical fertilizers are a great quick fix, but it's not the utopia that people say. We can use these type of waste products safely in our soil and never use chemicals. And it's a lot better for everybody.